So welcome, and thank you all for joining our webinar introducing a new cost-effectiveness calculator for residential energy efficiency programs offered by the Better Buildings program of the U.S. Department of Energy. I have a few housekeeping notes first. To avoid background noise, all phones will be muted during the presentation, but your observations and questions are welcome. So please use the chat window to send your questions and comments, and we'll be collecting those for a Q&A session at the end. Slides from this webinar will be posted within the next few days at the Better Buildings Solution Center. You'll also see a link at the tail end of the presentation, as well as at our website at the Berkeley Lab Electricity Markets and Policy Group. We'll be adding a recording of the webinar in those two locations as well. So now I'd like to turn things over to Dale Hoffmeyer, who first saw the need for this work. Dale is the acting team lead for the Better Buildings residential program, and he works to accelerate energy performance improvements in existing residential buildings using integrated building systems approach to achieving maximum energy performance. He also leads DOE activities to demonstrate how energy upgrade programs can streamline processes to serve more homes across the country. Dale?
Thank you, Ian. I appreciate that. So I'm just going to give a very brief introduction here. And what I'd like to say is a couple of years ago, we had been talking with some utility programs that were running whole home upgrade programs and other kinds of residential programs at utilities. And some of them were facing some challenges with cost effectiveness. They were not all the same, but they were having different challenges. Some were dealing with low natural gas prices. Some were dealing with changes in the cost effectiveness tests being used in their state. And some were facing other kind of challenges with their programs and meeting cost effectiveness. And at the time, we had a beta version of this tool, this calculator that Ian mentioned, and I thought maybe that could be used to do some sort of scenario analysis, better understanding what some of the inputs to cost effectiveness tests affect the output of those tests. And so I had asked Ian and working with E3 to make some changes to this beta version of the tool that we had at the time, but also doing a webinar talking about how you could use it to better understand some of the inputs and how they might affect the output, specifically when there are residential programs that are facing some challenges meeting cost effectiveness, and just having them have a better understanding of why the results come out the way they are. So that's what kind of was the driver behind this. There are a number of other, there are some other efforts right now, some other organizations that are working on cost effectiveness and looking at new approaches. And I think Ian's going to talk a little bit about that in here. This isn't really getting into some of those new approaches or looking at more of a looking at the cost effectiveness tests and making some changes there, or getting more of the value, not the benefits as well as the cost, quantifying those in the cost effectiveness tests, which is a good thing. This isn't really getting at that, although you can use a calculator and can include some of those things. But those are some good things that are going on too. So I'll just leave it at that and turn it over to Ian, and the other presenters, Snu and Eric and Kiran, who are more of the experts in this. I am somewhat familiar with cost effectiveness and the cost effectiveness test, which we're going to give a little overview on. But the tool is a little easier than the original version, but still there's a lot of detail there, and sometimes you may need to rely on some other experts to kind of run the numbers for you. But hopefully this is going to be helpful. So I'll turn it back to you, Ian.
Thank you, Dale. So here's just a quick look at where we're headed with the presentation today. First, I'm going to talk briefly about the policy context and the need for the tool, provide a little more detail on what Dale just covered, In general, we're going to talk about why there's a need to assess cost effectiveness. And we're going to talk about some plausible uses of this tool. And we're also going to get into what Dale mentioned a moment ago, that there's some new thinking about cost effectiveness policy and practice, and maybe something about how this tool relates to that. Next, I'm going to turn it over to Snuller Price of Energy and Environmental Economics. He's a nationally recognized expert in this field to talk really about the methodology and applications in cost effectiveness, and he's going to walk you through kind of what the basics of cost effectiveness screening are and some of the basic tests. And then two of his colleagues, Eric and Kiran, are going to talk about the tool itself, its structure and the inputs, where some of that data might be found. And we're going to go through how you would construct, move from measures, building from those to programs and up to to a full residential portfolio. And lastly, kind of how to read the results, and then also to try out some use cases. The tool has the ability to do some sensitivity testing. We're going to run through some scenarios that might be, of interest to people on the webinar, and also show some additional functionality for some other needs that might come up down the road. Lastly, we'll take your questions. So, why is it necessary to do cost effectiveness analysis? The most basic reason is just to ensure that ratepayer dollars are best invested, given the many different kinds of policy objectives that regulators have. It allows the regulator to assess kind of the budgets for efficiency program administrators and to look at their performance over time. From a resource planning context, it does allow one to rank energy efficiency programs, both in aggregate and individually, in the resource mix, and to have some feel for the kind of cost and performance risk that they might assign to energy efficiency. For program administrators, it of course allows them to look at demand-side potential, to look at a variety of different pathways to achieving an energy savings target, and to rank different resources and develop a portfolio, and to develop the budgets necessary to implement that portfolio. So as Dale mentioned, this is the second version of a tool that was published a few years ago. And it has a number of strengths, and chiefly it uses a common, very established cost-effectiveness methodology. It's the methodology laid out in the California Standard Practice Manual. And this, the SPM has been the prevailing guidance on cost-effectiveness screening since the 1990s, and it is cited in, as far as I know, every state that has significant energy efficiency programs as the foundation for their cost-effectiveness screening practices. One of the benefits of this tool is that it's transparent. It's not a black box. A lot of the commercially available tools it's a little difficult to see exactly what's going on under the hood. Here it's in a standard spreadsheet form. It's pretty easy to kind of diagnose what's going on and to really kind of dig in and understand the nuts and bolts of cost-effectiveness screening. And lastly, it's publicly available. Most of the tools out there are proprietary. They can be rather costly. Often you have to have a consultant run it for you. We think this is simple, and it's public, and so it should be very accessible. So again, these are some of the uses of cost-effectiveness screening here, and I'm going to suggest to you that this box down at the bottom really highlights the kind of the sweet spot of uses, of potential uses for this tool. That it can be used because it's public, because it's available to all stakeholders in any jurisdiction. then it can be used by the program administrator to develop their portfolios and to do some scenario testing of their portfolio against different possible futures, and to maybe even optimize their programs to screen measures and try to find the ones that are best suited to the objectives of the program administrator, but also to reach out to other stakeholders and allow them to independently look at alternatives, alternative measures and programs, and then also to, again, look at, well, what would the outcomes be if you envisioned some change in cost-effectiveness policy or some change in the economic environment in which these programs are implemented. And again, as Dale mentioned, there's always been a lively dialogue in the energy efficiency community about the best ways of screening programs for cost effectiveness. And I'd suggest that dialogue really has matured lately, and that we've seen some very helpful publications on that score from a consortium of folks now known as the National Efficiency Screening Project. It's a group of about 40 experts from around the country. They represent a broad array of stakeholder perspectives. They include program administrators, implementation contractors, installation contractors, and other types of trade allies, advocates of various stripes. And they're kind of united around this idea that there needs to be some more overarching guidance on the policy and practice of cost-effectiveness screening than is currently offered by the California Standard Practice Manual. That's been subject to some critiques, and the project has tried to address some of those critiques in a series of publications, one of which I commend to you is the Resource Valuation Framework. It has a number of principles laid out there for choosing a primary test and to kind of look at the merits of finding some symmetry between the costs and benefits of economic screening, and then kind of laying out some principles for the selection of not only the test but also discount rates and the definition of benefits chiefly tied to specific public policy goals. It also argues that there are a number of benefits out there that are indeed hard to quantify, but they argue that even if a benefit is hard to argue, it's still a benefit, and that there ought to be some way of taking it into account. A lot of the principles that were laid out in the Resource Valuation Framework have been elaborated in much greater detail in a document that is still in draft. I think it may come out as early as next month, called the National Standard Practice Manual. And it's going to provide more detail on these principles and concepts and methodologies applied not only to energy efficiency, but also to the full array of distributed energy resources, including renewables and cogeneration and so forth. And so I think with that, I'd like to turn the presentation over to our colleagues at Energy and Environmental Economics. We're going to start with Senior Partner Snuller Price. He's been a pioneer in developing standard methods for cost-effectiveness analysis of cogeneration, demand response, electric vehicles, energy efficiency, and building standards. SNU, many of you may be aware, wrote one of the primary resources in the field. That's the 2008 NAPI Guide to Understanding Cost Effectiveness. He has more than 20 years of experience supporting utilities and state and federal governments on energy policy and resource planning. And he has pursued a number of topics across the entire power sector. And so with that, I'm going to hand it over to Snu.
Thank you, Ian, and thank you all for joining us this afternoon. What I plan to do over the next 7-8 slides before turning it over to Eric and Kiran is just to give you a little bit of a flavor of what you'll find when you open the tool, sort of where it comes from, what its sort of origins are in the utility space, so you kind of have that general orientation. And then Eric and Kiran are going to go to successively greater levels of detail when we're looking at the tool, screenshots, and so forth. When we first developed this tool, the version 1.0, the reason for it was that there were a number of whole building programs that were getting funded through the ERA funding. And what we wanted to do was create a tool that nested all those program managers, some of you may be on the phone, in the vocabulary and the process that are running in each of the state commissions that is used to basically fund those programs. So how do you ask for the money? You need the vocabulary. So what I want to do is sort of talk about what the basic vocabulary is, what it is, how it works, and then with that we can do a deeper dive into sort of how exactly it works. So that's what I'm going to try to do. So cost effectiveness basics. You can make anything look simple in a three-step process. Each of these steps may not be quite as simple as a bullet point on PowerPoint, but basically what we're doing is, what is your cost of your program? So that could be what we call incremental measure costs. It could be incentive costs. Could be, depending on your perspective, a number of ways of characterizing sort of which cost. But the idea is you really need an accounting of what we're spending. Step 2 is evaluating the change in costs of your preferred supply plan. And where this comes from is the sort of utility history and resource planning. So with load growth, how will the utility or market add resources to meet that need? And if I can do energy efficiency, then I avoid that need, and we call that avoided costs. And so another word for avoided costs are benefits. So in a traditional utility planning process, those avoided costs look like avoided fuel in the power plant, avoided capacity, avoided construction of a new power plant, that type of thing. As we will see, looking at cost effectiveness perspectives that are broader than just that sort of narrow utility view, you start to enter things like cleaner air, reduced GHG emissions, impacts on water systems, and other things that have been avoided because you're doing energy efficiency. So that's step 2. Step 3 is you compute the difference, benefits minus costs, or you do the ratio, benefit-cost ratio, and then, generally speaking, the way this is done is through a life cycle analysis, so over the life of your program. So if you're doing an LED light to replace CFL, you're going to have a look out over the life of that lamp and see how it performs both costs and benefits in the framework, and NPV allows you to roll it all up. So that's the basic idea. Then the sort of first area of complication is that cost effectiveness is really drives the question cost effective to who? And there's a number of ways to look at this. In the standard practice manual, there are 5 different tests that are defined. As Ian mentioned, there's a lot of debate about which is the right test or the wrong test. To me, I think that the easiest way to understand it is that each test answers a different question. So it's not sort of, you could ask which one's the right or the wrong test for doing screening or deciding which programs to fund. But essentially, each test is a legitimate test. It just answers a different question. The tests are broadly organized as sort of more social or broader tests. So is it good for the state to do this program, or is it good for society as a whole? And then there's other tests in here that try to parse society into those who are participating and non-participating and the utility. And so those are more distributional tests. So even if we have benefits overall from a social perspective, are there winners and losers, and do we need to worry about that? And usually, in most states, they start with the societal test or a social test, whether it's the TRC, which is most common, or a societal test that begins to add in more externalities. to decide whether it's a good idea to do that program. And then they use the distributional tests to sort of measure, whether the incentive should be more or less, or other design details around the program to get a good balance of sharing of costs and benefits among participating customers and non-participating customers. So I think we have, we'll get to it in a second, a little bit more detail around the total resource cost test, and we wanted to focus on that because most every state looks at that as a sort of primary test. As Ian mentioned, there's a number of, a lot of work going on sort of what should be that primary test just to decide what's in the portfolio. One of the challenges of developing a tool like this that's sponsored by the DOE, it is intended for use across the country, is that we have 50 state commissions, and while they all use the standard practice manual, they all use it a little bit differently, and they all have their own tweaks and their own adjustments. So we've designed in the tool a number of ways to accommodate differences between states. So you'll see that in there. And the differences include, even what costs or benefits are included in each test, but also formats for the input. Like some places have their benefits characterized by one number, others by, hourly for the whole year type of numbers. And so there's a number of differences, and we've tried to accommodate that in the tool. I think that the first 3 bullets on this slide just talk about some of the differences and the nuances between ways states treat the sort of overall broad test. And then the program administrator cost test is used to look at from a revenue requirement. So do my bills go up or down? And then there's a RIM test, which is really looking at rates going up or down, and it's a non-participant test. So, I think that the best practice is to get an understanding of your program's overall TRC, and then getting an understanding within that of, how does the proposition look to the homeowner or the renter, and then how does the program that you're looking at look to the non-participating customers on the system. And if you can, I know it's a little bit alphabet soup if you haven't been working on it a lot, TRC, PAC, PCT, RIM, but, we've used that vocabulary on purpose so that basically, you can be sort of steeped in the right language when kind of putting together your portfolio and understanding its cost effectiveness impact. So a little bit more drill down on what the total resource cost test is. And what you will see is on the left there's a number of benefits, and those benefits can be benefits from sort of a broad social perspective. So they could occur to the utility or to the customer itself. The TRC focuses on financial costs and benefits. So these are things that are, people actually writing checks for or receiving checks from. So looking at actual money flowing through the system. So under the utility bucket, avoided energy purchases from the wholesale market or fuel in the power plant capacity, T&D, environmental controls, losses. These are all the things that it takes to deliver, a kilowatt hour of electricity. From a customer perspective, O&M savings. So, for example, if you switch to LEDs and they last longer, they have less maintenance on the folks. That's a benefit from a TRC. And then, depending on which state, other resource benefits get included as well. Often natural gas savings, if it's some kind of shell measure, which I know we're talking about and focused on here, it would be a biggie, and as well as some places water or other components. And then the costs of this are running the program, the evaluation of the program, the equipment costs, and usually the equipment cost is defined as an incremental measure cost. So if I'm, again, doing that LED, how much more did the LED cost than the CFL the customer is going to buy anyway, or the incandescent? And then the O&M cost if there's additional costs of maintenance. So this gives you sort of this broad look at whether your program or portfolio is a benefit from a regional perspective. And again, it doesn't consider who gains or loses. So notice on the TRC, there's no arrow that says incentive to the customer to adopt this. The incentive would come from the utility arrow down to the customer if we were to draw it on here, but that's not really the issue. The issue is, should we do the LED overall? And then the second question is more of a distributional. How do we get the customer to make that decision? We have other tests that look at the customer benefit, the utility benefit, and so on to sort of carve that up and design the program. So I want to talk about a few things that really drive the results, because I know everyone's interested in, well, once I put all my data in and go through all of that effort, what's really going to swing the answer, and how can I design my program to pass and be cost effective? So one of the key drivers is the discount rate. So again, we're doing life cycle benefits and costs, and we're talking about, especially if we're talking about whole building measures, we're talking about things that will be there for a very long time. And so how you discount really drives the needle, especially given that we're talking about upfront investments that pay back over a long period of time. So the lower the discount rate, the much greater your benefits are going to look. And this is why whenever you go to a energy efficiency, cost effectiveness discussion, everybody's always wanting to know what the discount rate is. And some examples in this slide about that I'm not going to talk about every number on, but you can see a pretty big swing for example, $1 per year for 20 years. If you have a 10% discount rate, that's worth $8.51 today, versus $12.46 if you're using a broader sort of social perspective. And most utilities use something that looks closer to this utility weighted average cost of capital. So that's one of the key drivers. The other key driver is the what's on the benefit side of the equation for the utilities. And again, that's the avoided cost. Here's a couple pictures from sort of the really detailed, granular avoided cost that California uses. Other states use a different, but essentially they have the same components. And just what's the value, what am I avoiding? And the sort of elephant in the room for a lot of the programs that we've been looking at lately is the natural gas prices. And so when you look at the forecast of natural gas, that drives both natural gas savings if you have it in your equation, but it also drives the cost of generating electricity down. Cheap natural gas in combined cycle gas turbine makes a low price of energy on the electricity side, so sort of both boats kind of are reduced. So this is a component. We've done a lot of work in the tool to accommodate avoided costs of different formats and so on. So hopefully, you will be able to identify the appropriate avoided cost forecast and stream for the analysis that you're doing. And then what we've done is in the tool put some sensitivity testing capabilities so that you can look at, well, what if this component or that component were higher or lower, and how does that affect the overall cost effectiveness of the test? So yeah, I was about to turn it over to Eric to sort of talk about the tool structure and how we use it, but it looks like there's a couple questions. Should I try to do those, Ian, now, or?
Snu, you're going to be available at the end?
Yeah, I can wait. Yeah, we can do it at the end, absolutely, and just sort of keep the...
And I've got a few for you, actually, racked up. So if you can hang tight,
okay, that sounds good. And then let me... I know that was a little bit of a whirlwind through the SPM and what it's there for, but hopefully it'll come clearer, even clearer as Erica and Kiran walk through the tool structure.
All right, yeah, so this is Eric Cutter, Director at Energy and Environmental Economics, and Kiran and I have been supporting the development of this model with Ian at LBNL for DOE, and we've also worked on a number of other energy efficiency reporting and cost effectiveness tools for various utilities around the country and state regulators. So we're going to go into increasing levels of detail. Please do kind of keep track of your questions. I think for expediency, Ian has us going through the slides first, and it will answer a fair number of questions by the end of the deck. And then we will also pull up the model and show it in live and show how some changes propagate through, and then open it up for questions there. And I'm going to now turn it over to Kiran to talk about the structure of the tool and start walking through from start to finish how to use it.
Great. So I am on the slide that talks about the tool structure, and this tool has been divided into 4 different broad categories. The first category that the user, when you open up the tool, you populate is the Initial Inputs tab. And the Initial Inputs tab is where you can put in your assumptions of retail rates, if those retail rates happen to be seasonal or an annual flat dollar per kWh number, or if they are TOU retail rates, where they have on-peak and off-peak components that vary. This is also where you enter the avoided energy costs, capacity costs, and in case of analyzing dual fuel programs or measures that have impacts on water and heating, you can also put in natural gas costs and water costs. The second tab, after you populate the Initial Inputs tab, is the Program Builder tab. This is where a user would enter details on all of the energy efficiency measures, the life of the measure, what the expected kilowatt hour savings from those measures are, as well as utility incentives available for each of those measures. And these measures can be all put into different programs, and the tool accommodates up to 5 programs with 10 measures each. You then move on to the Portfolio Builder tab, and the Portfolio Builder tab is where a user can populate the composition of the entire portfolio and how many programs of each type are being tested to consider the cost effectiveness of the portfolio. This is also where the user can input overhead costs that are not necessarily tied to single programs, but to the entire portfolio in general. Once all of that information is populated, the user has the option to click a Generate Report button that will then lead the user to the Report tab, where all of the results can be looked at. So the Report tab summarizes the portfolio impact, the benefit to cost ratios, as well as some charts that go into detail by component of how those benefits and costs are split out. Also on the Report tab is the option to perform sensitivity analysis, and the user can do sensitivities on retail rate escalators, gas escalators, administrative costs, and a few other criteria that we can go into when we do a live demonstration. So on the next slide is a snapshot from the tool, and this is where the user can decide which of the cost tests are most relevant and have to be analyzed. And this is more of a reporting issue. So the user could decide to report just the PCT, which would be the participant cost test, or the PAC, which is the program administrator cost test, and decide not to report the other 3. And then in the snapshot just below that is the allocation of benefits and costs to different categories. So whether or not the electricity, natural gas, fuel oil, and water calculations should be accounted for when looking at the cost test from the utilities perspective or the participant's perspective. So the user can make these true or false depending on how they want to define the cost tests and which components they want to include in it. So on the next slide is a snapshot of all of the financial inputs that the model looks at, and in that the user can enter an inflation rate as well as discount rates from each of the utility, societal, and participant perspectives. And this is also where the user would enter escalation rates for the different fuels that are being considered in the tool, namely electricity, natural gas, fuel oil, and water. On the next tab, you'll see this is what the tab where a user can enter energy efficiency load shapes looks like. And there's two ways of entering energy efficiency load shapes for different measures. One is if the information available is in the form of TOU blocks, then the user can populate just the percentage savings in each of the block that is expected with each measure. Whereas if there is more detailed data available at an hourly time set, then those can be entered in the hourly format as shown in the snapshot below. So if you look at the user-defined load 11, that's an 8760 input array where an hourly profile could be entered. On the next tab is a snapshot of how the generation avoided costs as well as capacity avoided costs are entered. Along with the energy costs and avoided capacity costs, the user will also have the option to include additional non-monetized costs and societal benefits, which are not shown in this picture. But there are different societal benefits that could be monetized and included in the avoided costs. And for each of the components, the user can enter an average annual escalation rates, which will be used for forecasting avoided costs in the future years. The next snapshot shows how the TOU period definitions are entered, and these can be entered in the initial inputs tab. And the user can define summer and winter seasons as well as each hour in those seasons and whether it's defined as an on-peak or off-peak period based on the relevant utilities rate schedule. So this was wholesale other resource cost slide shows the other values that can be input, which are namely natural gas avoided costs, fuel oil avoided costs, as well as water avoided costs. And if any of the avoided costs that are societal or capture externalities are not input in the existing cells, there's an option to add those in the inputs tab as well. So this, again, the retail electric rate slide is a snapshot from the initial inputs tab. And this shows that the retail rates can be input for up to 5 different customer classes and can be input either at the TOU time step or an annual time step, or can be seasonal, so the same dollar per kWh value for summer as well as winter. These can be broken out into 4 categories. Here the values are populated as being the same. But if you look at customer class 5, you could have a summer rate that's higher than a winter rate for a summer peaking system. Similarly, the retail rates can be entered for natural gas, fuel oil, and water in the same initial inputs tab for up to 5 different customer types. I'm going to let Eric cover slides 93 and forward.
So from here on, we'll show how these inputs were built up from measures to a program and then from programs to a portfolio. And I'll say at this juncture as well, you'll notice the inputs for the avoided costs and for the retail rates are purposely kept fairly simple, a single number with an escalation rate. This is to keep the model simple and approachable, but also to make it very easy to do a sensitivity analysis, which we'll show at the end. There are other tools that allow much more refinement of how avoided costs for energy, for example, change over time or change by season. But really the purpose of this tool was to give a first level analysis of cost effectiveness and allow the user to do a fair amount of sensitivity analysis fairly easily. So we'll start here with a snapshot of the programs. And our tool, as Kiran said, you can build up to 5 programs. The model we're showing is pre-populated with some example programs that we'll go through, starting with a lighting program, and then there at the bottom a new home construction, in the middle a whole home retrofit, each of which are built up by a number of measures. And so this shows an example for a lighting program. Up to 10 measures. Here we're showing 3. And you can do this in either by, as we've done here, just having 1 unit per measure installed. And you'll see 15 watt, 20 watt CFLs, and then there are other measures which are defined as both what kind of light bulb are you replacing and what kind of new efficient light bulb is being installed. You can also use this to define a typical household, for example, and that might say that a typical residential household would have 3 15 watt CFLs and 4 20 watt CFLs, and then build up a program, say, at the home level. Excuse me. So we have each measure is 1 row and defined by an incremental measure cost, which is how much more this light bulb in this example costs compared to a inefficient or standard light bulb. And then one thing we are highlighting here is, so there's an incremental measure cost. You can enter, so all these cells in yellow can be modified or updated or changed. There is an incentive that the utility is paying per light bulb, and then a load shape associated with, in this case, with lighting. And if no load shape is selected, you'll see conditional formatting highlighting that, and that's to prompt the user to go in. And we purposely leave this, we want the user to kind of have to go through and select these rather than default, because it's fairly easy to change one thing and not another. So rather than, we want to point the user to where to make the fix rather than kind of automating the fix for you. So that's an example of one program. You can enter up to 5. And then we go from a program to a portfolio. And so you see each of the 5 programs listed here on the top table. And again, all the cells in yellow are cells you can enter. And here you can select across 3 years how many of each of these programs are you implementing. And so we've selected 6 of the lighting and then 1 of each of the others except for the HVAC and water heating rebates. And you'll see it calculates an incentive budget, which will be built up based on the incentives back here that were entered for each of the measures in each of the programs. Now, this is where we can also enter overhead costs that aren't associated with a particular program or measure. One way is per install. So for each installation of a residential lighting program, how much overhead is associated with that, and again across 3 years. And then down here at the bottom are general overhead across the entire portfolio, so not even associated with a particular program, but they're often admin and marketing are designated by utilities for their entire energy efficiency program and not broken out by program. So it gives you the option to be more specific or less specific, and then calculates the total overhead and budget there in the green, which are showing formula calculations. Next couple of slides I want to highlight. So here are looking at the details of 2 programs. So we have the lighting at the top and an appliance on the bottom. And I want to just call your attention to the lighting program, which is saving 352 kilowatt hours per year. So these are annual energy savings at an incremental measure cost of $129 per installation. Now compare that to the appliance, which is much, much more expensive, almost 10 times more expensive in terms of the cost of the appliances naturally. You've got $1,300, and it's saving, but it's not quite saving 10 times as much energy. So we're saving 1,000 kilowatt hours. You'll see this reflected in the TRC of these programs. The residential lighting is coming across as more cost effective. So you'll have a TRC of 1.85. Whereas in this case, the residential appliance, given the higher cost but not sufficiently higher savings, is not showing as cost effective in the TRC. And when we go back, the number of programs that have been selected by the user to be installed, that is resulting in an overall program portfolio that is TRC cost effective, just barely, given the weightings of each of these individual programs. And so that naturally illustrates how one can, there may be a number of reasons for promoting a program that itself is not TRC cost effective or a particular measure. And in many states, the emphasis is the overall portfolio cost effective. And that might be, for example, for an emerging technology program like LED light bulbs used to be, they're not so much anymore, or for low income programs, or for hard to reach segments that have, for other policy reasons, are a priority. And then finally, the results for all 5 programs in the portfolio are shown here graphically. We have the benefits on the right-hand side and the costs on the left. So for each of these cost tests, if the benefit bar is higher than the cost bar, that is passing that cost test. And you can see this TRC over here. We had 1.03. Our benefits are just exceeding the costs. And with the addition of societal costs, the societal cost test is coming out as a higher ratio. And as is common for most efficiency programs, the ratepayer measure is negative or below below 1, but that is a fairly common result. And here I'll turn it back to Kiran to discuss the sensitivity analysis and some of the features of the model. Once you've seen the results, how you can explore them a little bit.
So on the sensitivity analysis slide, you can see the different inputs that you can test and analyze the impact of these inputs on the cost test results. So as we talked about in the beginning of this presentation, discount rates are a key driver of results, and lower discount rates usually place a higher value on benefits that are accrued later in the life of the measure. So lowering the discount rates would likely give you better cost effectiveness results. Similarly, the escalation rates can be used, And testing these sensitivities can give the user an idea of if fuel prices are expected to be low or energy costs are expected to be low, leading to lower rates in the future, how that would impact the cost effectiveness of different programs and portfolio. Similarly, the user can also do sensitivities on administration costs and incentives, and how having different levels of incentives for each of the programs can change the cost effectiveness tests for certain perspectives. For instance, higher administrative costs will make the program look less attractive from the utilities perspective. So the PAC might have more unfavorable results if the administration costs are really high. So some of the use cases that the model is capable of running and that demonstrate the capabilities of the model are described on this slide. The three use cases that we highlight are persistence of low or moderate fuel prices. So the model can take inputs for lower gas as well as fuel oil and water prices, and that combined with low escalators for each of those fuels can help test the scenario of persistent low or moderate fuel prices. Similarly, the model can analyze the impact of shift from a single fuel to a multi-fuel program. So for each of the measures, the user has the option of entering impacts on heating as well as fuel oil and water use. And so there could be measures that would have large electric savings but may negatively impact heating, and the model can analyze the impacts of measures that affect both. Similarly, the model can be used to test out changes in cost-effectiveness screening policy. This can be done in two ways. One would be to enter the non-monetized benefits as a monetized proxy in the societal inputs in the initial inputs tab. And then the other would be to lower the threshold for cost effectiveness. So for instance, if the cost effectiveness threshold is usually at 1, in order to account for non-monetized benefits, that threshold could be reduced to 0.9 and qualitatively account for the fact that there are other policy needs or goals that are being met with the program. So the next few slides just go through the demonstration of each of these use cases. So the first case we talked about was persistence of low or moderate fuel prices. And the screenshots here show where a user would enter the relevant information. So this is again the retail rate projections, and low gas prices could be entered in the marginal natural gas rate. And then the corresponding escalator for natural gas could be set to be really low, and that would create the scenario of persistence of low or moderate fuel prices. Similarly, the avoided energy costs could be set to a lower value, and the avoided energy costs escalator could also be set to low. The second case shows a snapshot of the measures and how each of the rows is a different measure. And the user can input the electric kilowatt hour savings as well as the natural gas impacts of each measure. So in some cases, for instance, there are savings. In this case, if you see the high efficiency clothes washer has savings both in the electric as well as natural gas cases, whereas for some others there are electric savings but the natural gas savings are negative, which means these measures increase natural gas use. And as I mentioned, changes in cost effectiveness screening policy could be accommodated in the model by looking at all of the different cost tests that the model can calculate, or lowering the threshold for the benefit cost test ratios, or adding in values to the societal benefits category in order to account for qualitative benefits.
So that covers the prepared material. What we'd like to do now, I'll turn it back over to Ian for any concluding thoughts, is I think now would be a good time to open up for questions, and we will also open up the model, which often helps to address particular questions. But let me turn it back to Ian to conclude and open us up for questions, and then we'll have the model ready to run through any particular demonstrations that are helpful.
Excellent. Thank you very much, Snuller and Eric and Kiran. So we do have a number of questions that have come in. I do first want to point out on this slide, you'll find a number of contacts there. If you have wonderful things to say about the model, direct those to Dale Hoffmeyer. If you have other things to say, direct them to me, if you would, at Lawrence Berkeley Lab. You'll see we're going to be posting the slides, and there are links there to the spreadsheet model, as well as to a fairly detailed set of user instructions and a list of frequently asked questions, and also a glossary of some of the terms that appear throughout the model. So getting into the questions here, this might be one for Snu. It says, how does the cost-effectiveness screening, how does that compare to or fit in with integrated resource planning, those processes?
Yeah, that's a great question. What is done in cost-effectiveness, we always try to remember to call it screening, cost-effectiveness screening. And remember I said that the benefits are the sort of estimate of things that the utility doesn't need to do if you do efficiency instead. So I burn less fuel, build fewer power plants, what have you. So you have this sort of static set of avoided costs. In other words, as much efficiency as I do or what have you, those benefits per kilowatt hour don't change, what have you. The more robust way to do this, in some places, such as in the Northwest, have done an integrated resource planning approach where rather than just assume I'm going to build a power plant and then see what I can offset with efficiency, I do the whole supply and demand portfolio together. So what's my least cost mix of new generation, of what type, what fuel, and when, and efficiency, what types and when, together. So if I do IRP, I don't really need to do a benefit cost ratio. I just do my least cost supply plan for customers. It's a lot more involved. I think that the Northwest Power and Conservation Council spends 3-4 years really in the analysis for each iteration of their integrated resource plan. And that's just way beyond the type of time frame and what have you that most jurisdictions will operate on. So the cost effectiveness screening that's embedded in the tool and is in place with for most every state is really this screening, which is, okay, I already did a resource plan. This is the type of resources it had on the margin. What's my estimate of how those costs would change if I do efficiency? So you can do it, an efficiency program planning cycle that's independent of the supply planning of the portfolio. So they're sort of related, but the cost effectiveness screening is a derivative of the overall resource planning process.
Okay, thank you. Another question that we have is, what kind of diversity, variability, I guess, do we observe in practice among the states and program administrators nationally in how they define the test, define benefits, and apply the test? Is there much spread there, or do people pretty much hew to the standard practice manual?
Yeah, there's I think probably others on the you may have your own perspective on this too, Ian, but I think every state has maybe one or two things they do differently. That's just like a little tweak. So that allowed us to do a tool that does each of the cost tests But you'll see, for example, in here, do I have fuel oil in or out, or do I have water in or out, or there's sort of adjustment. So it's essentially, I guess it's similar, but every state has its own strange thing when you get down to the absolute detail of it. My experience, California probably maybe a few more than a few, but it's generally all the same concept and framework, but the implementation of which costs to include and which benefits to include and when vary.
Yeah, I'd second that. I guess at one point, just out of curiosity, I tried to kind of classify the variance on the total resource cost tests that were applied out there, and I think I came up with at least a half dozen different variants, and they, it's along the lines that Snu just described, whether or not they include fuel oil, for example, or water. But sometimes it's significant where they're maybe using a societal discount rate, or maybe allowing some societal benefits for certain programs or measures where the program administrator has been able to persuasively document those benefits and their quantification to the satisfaction of the regulator. There are a number of folks that do have in their regulation some opening there to countenance those, to contemplate those types of benefits if they can be established. So there are a lot of variants out there, but I guess I want to point out that there are ways, and maybe Eric and Kiran can demonstrate in a little bit, but there are ways of kind of effecting some of those changes with this tool with some limitations.
Yeah.
Another question we have is it ever acceptable? Are there any circumstances under which one might use different tests for different types of measures, say a total resource cost test for lighting measures and a societal cost test for motors and fans? Is there ever a situation in which that might be appropriate?
I can't think of any. I mean, I would strongly say that you got to use the same test for across all the different. Otherwise, what are you really testing? It seems like there are other ways to create flexibility in the underlying portfolio than kind of putting your foot on the scale or changing the cost effectiveness test for one program or another. There are a few of those. One way is to measure cost effectiveness at a sort of a higher level, like at the portfolio, the way Eric showed. So not each individual program has to be strictly cost effective, or even within a program each measure. And there are other things you could do that create, and maintain uniformity, so the results are understandable but still provide a little bit more flexibility, which is the only reason why I could think of you would, use a different test for a different type of efficiency measure. Okay.
Let's see. Someone's asking, where do the values in the tool come from for measures? The assumptions regarding cost and savings. I'll take that one. Pretty much all of the values that we have for cost and savings for the measures come from the DEER database or filings of the California IOUs, and so they do represent values that have been arrived at after years of evaluations and modeling. You'll notice that we do include interactive effects, that there are some measures out there, particularly on the lighting side, for which you end up with an increase in gas consumption, and so we end up kind of losing some savings up at the portfolio level in some cases. I think, but the costs and the savings that you're seeing there are pretty specific to California. We had to choose some, and so those are the ones that we settled upon, in part because a number of places do actually borrow values from the DEER, and that's the database of energy efficiency resources, I think, what DEER stands for.
Mm-hmm. A lot of states do have what's called a TRM, technical reference manual, that does specify incremental measure costs for common measures and so on. So, if the numbers are not looking quite right and you're working in a different state, there might be a TRM, or there might be a TRM in an adjacent state that looks more like yours in California.
Yes, I guess I would point out that we in the Electricity Markets and Policy Group at Berkeley Lab have a fair amount of work on out there on technical resource manuals, on and contemplation of what would it take to move towards regional or national technical resource manuals. And so I guess I would invite folks to navigate over there and peruse some of the publications that we have, and also some of the publications that we've done in support of the C Action or State and Local Energy Efficiency Action Initiative under the EM&V working group. Let's see.
And Ian, those measures that you've included in those are just for illustration or examples, not that people they're not stuck with those. They can enter information if they have information on what.
Absolutely, that's absolutely true. And the same thing with the load shapes. I think Kiran mentioned that and maybe showed, but there's abundant opportunity in the load shape library tab to put in your own kind of distribution sense of how the energy savings are distributed across the 8,760 hours of the year. So there's a lot of flexibility here to adapt the tool to your local conditions, both on kind of the supply side and on the demand side. Let's see, one more question here is, let's see, someone's asking about how would one incorporate AMI data on that measure the impacts of specific measures? One example is, PG&E. They have a pay-for-performance pilot out on the street now, and how would the measured energy savings from such a pilot be incorporated into, say, the descriptions of the savings assumptions on slide 24? Anyway, Snu, do you have some thoughts there?
Yeah, sure. I'll chime in. We'll have to pull up slide 24 if I'm going to comment on that because I don't remember exactly which one that is. But AMI, I'm really actually pretty excited about the future of AMI in energy efficiency for a mechanism to measure the performance and do performance-based programs, because that will allow us to be more innovative on the energy efficiency side. And as long as you show up with the savings that can be measured and verified through AMI, then it seems like that could be a winner, and it would get us out of sort of a deemed savings, widget by widget approach to energy savings. And I think for folks here on the phone that are working on whole building programs, that's especially important in terms of the future. What this tool, though, is designed to do is to do cost effectiveness with some assumption of future savings. Those could be informed by AMI related EM&V, but some expectation of future savings, and then look at cost effectiveness of your programs. So the AMI performance-based programs, you could input that in here, but I think you would, but this tool is designed to help get you. It's just fits into the policy making and the assessment of your energy efficiency program a little bit differently than an AMI performance. This is sort of a before the fact forecast. But that said, if you had some AMI data from one of the PG&E pilots or one of the others that had, say, what the resulting savings were from a whole building program like the one you intend to run, you could absolutely fit that savings shape into the load shape library and then, put in your cost of your program, what incentives, what have you, and it would run the standard cost effectiveness tests. That gets a little bit away, that gets a little bit away from, and I don't know how much of an extended conversation we want to have on sort of a performance-based program idea, but that gets away a little bit from the flexibility you get by having a performance-based program. If I have to assume my program is going to look just like this other one that I'm taking the data from, really the concept behind the performance-based is you don't have to do the a regulatory filing about what your expectations are. You're taking the risk of the savings on yourself, and then you'll see using AMI as the program rolls out. So I don't know. It might be it's like just opening the door on a whole area, but I think it's a really good question, and one that I think is important particularly for the whole building folks.
Thanks very much.
Ian, this is Eric. I'll quickly add it. As Snu was talking, I was entering a measure just as an illustrative example. It is possible, and I've seen utilities do this, where they're defining a program around a whole home retrofit, and they're including behavioral measures or information display measures or things that aren't tied to a particular measure. One way to do that is to put it in here as a measure that has zero cost. If you're, literally, or maybe it's a very small cost, but you're literally saying this has been enabled by AMI, and this is a benefit. You can also then add a cost at the overall program or portfolio level and allocate the admin or some of the enabling technology that isn't particular program. And so maybe there's an in-home display cost that goes measure by measure, or maybe there's some utilities hire O-Power or someone else to send out bill inserts or send out information relative to their peers, and that can be done not measure by measure, but on a program or portfolio level.
Okay, thank you very much, Derek. That pretty much rounds out the questions that we've received in the chat box. If you would like to kind of get into the model a little bit and maybe kind of try out some sensitivities and give people a feel for the flexibility of the model.
I'm just going to get rid of that one. All right, and why don't if there are no other questions, we could go through one of the sensitivities that Kiran outlines and start there.
That's great.
Okay.
Maybe go ahead.
So these are all similar to what we showed on the slides, where we put in. One thing to note is that we did a very simple one measure per program, which obviously you can be a lot more conscious about how you design a program, and you might, for example, recall that our appliance rebates were coming out as not cost effective from the TRC. So we have two programs here which are below one. One way to try and design a better program is simply eliminate ones that aren't cost effective or add more ones that are. Without going detail by detail, we can. Oh, I'm going the wrong way because we've made it big so we can make sure everyone can see. And so the TRC typically uses a utility discount rate, and a utility WACC, a weighted average cost of capital, We use around roughly 7%. You might be a municipal utility and want to see something closer to, say, 5 or 4%. And so you can either use the kind of click slowly with the slider or move it fast with the bar, and you'll see as we make that utility discount rate lower.
A lot lower. 0.
I said 0.
Oh,
yeah, and then
no, we don't want to do 0, yeah. You'll see the bar charts over here updating, and you recall it before our TRC was 1.03, and now, but with a very low discount rate, we've made it significantly more cost effective, for example.
There you go.
Yeah. One way to avoid that issue we were just having is to make the calculation manual, and that way you can change this without it updating constantly. And then calculate sensitivity. We'll run the macro. Now I've made it a high 9%, and my TRC is now below 1. So that's a little more user-friendly if you're doing sensitivities. If you're just entering numbers, turning the calculation to automatic is a little handier. Maybe I'll ask Kiran if there are other examples to highlight with the sensitivity you want to go through.
We can also test out the escalation rates and see what they do to the results. So if we had a higher electricity escalation rate, it would probably make the PCT more favorable.
Mm-hmm.
Similarly, I don't think we have a lot of measures that have dual fuels, but the few that do will probably get impacted by having a higher natural gas. So that also made the PCT higher. And the reason they are moving only a little bit right now, despite a huge change, is because we have very few measures that have natural gas impacts, and those are small.
Mm-hmm.
And then we could add administration costs that would make the program administrator test look worse. So the costs went up and the benefits relative to the costs look worse now. But these are the sensitivities that the user can test out. And the slides on use cases describe how these can be used in combination with different initial inputs to have different scenarios that look at low fuel prices or different cost effectiveness thresholds, etc.
One of the things that I'm thinking about that might be interesting to folks on the call is if you're doing a program that's a whole building program, I think that the question is really, how do I make my program cost effective? And one of the things you can do in the tool, I don't know if we can do it live, but is you can make your whole building program composition such that you add more cost-effective components, for example, lighting, to the package, and so that your overall new home program becomes cost-effective. And I think that there's a few sets of inputs that definitely drive the result that are decided at already in your TRM or at your state commission. But the thing that you have more control over putting a program together is, what are you offering to the customers, and putting together a portfolio that kind of counteracts some of the natural gas or other changes is the first place I would look if I were trying to design a whole home program to show that the combination is cost effective.
Yeah, and a quick way to look at that here on the Program Builder tab, we highlighted in the slides a little bit, but you can see, for example, quickly by looking at the measure cost and the electricity savings, the measures so here, for example, are two measures with fairly similar savings, but one costs twice as much as the other. So some scanning along those lines, you can either make that 0 or you can make this 4. Well, I guess you don't want to have, well, maybe 2. Often you have 2 freezers per household, perhaps, but if you really want to push it. But you can
just don't buy them another one to do this.
Same thing on the lighting. Some of these are, here is a very cheap measure with a lot of savings. So if you can justify giving 6 of these per home instead of just one, that's one of the ways the tool can help design a program. And I will say, in working with utilities, the DEER database is well researched. There's a lot of research and investigation behind it. Still, an awful lot of utilities will look at that and say the costs don't really reflect what I think are accurate for my customers. The costs are one of the areas, I'd call the weaker areas of the DEER database. The savings are pretty darn accurate and modeled well. But you'll see utility by utility saying, look, I really know my customers in my commercial space are installing freezers for a lot less than what DEER is showing, and that's perfectly legitimate. Typically, in regulatory programs, someone who's reviewing that will ask for some justification, which can be a simple calculation or some more detailed work papers. So all that is what's to say the DEER is a good resource, but you don't have to take it as gospel by any means.
Yeah, it's a perfect starting point, I think. But yeah, might tune it up.
Okay. Well, thanks very much, guys. I appreciate kind of introducing some clarity and bringing it into the real world. If I do have one last question from the floor here, where someone's saying, can you show where one can account for interaction between measures? And I think let's see, maybe on that slide 24 or back on the model on the program builder. Either way, there, whoever's driving. You can see that there are a number of values there. For example, that are, on the gas side that are listed as negative. They're in red with parens. And so, that's one way in which we account for those interactive effects. And when you get kind of into the calculations tab, we haven't really discussed that, but there is, there's a couple of tabs here that really are, the nuts and bolts of the machinery behind the tool, and you can see there where essentially you lose some credit, some of your monetized savings, you lose some of that for the change in natural gas consumption. So with that, I think we'll close out today, and with our thanks for joining us. And again, the webinar. Both the slides and the recording of the slides will be posted on the Better Buildings Solution Center website in the next couple of days. And once again, thanks for joining us.